Welcome friends, today we'll be discussing solved examples on equations of motion. First example is a train starting from rest attains a velocity of 72 km per hour in 5 minutes. Assuming that the acceleration is uniform, find the acceleration and the distance traveled by the train for attaining this velocity. So here in this example, acceleration is uniform and two things are asked: the acceleration and the distance traveled by the train for attaining this velocity, that is 72 km per hour. So first write down the given data. We have been given u equal to 0 because at the beginning train is at rest, so u will be initial velocity will be 0. V equal to 72 km per hour. Now 72 into 5 by 18 will be equal to 20 meter per second. Whenever you have to convert kilometer per hour into meter per second, multiply the kilometer per hour value by 5 by 18 and you will get the answer in meter per second. Time t equal to 5 minutes, that is 300 seconds. So acceleration equal to change in velocity divided by time. So v minus u divided by t. 20 minus 0 divided by 300 equal to 1 by 15 meter per second square will be the acceleration. Now second thing asked here is distance traveled. V square equal to u square plus 2s, that is 2s equal to v square minus u square. Initial velocity is 0, so s will be equal to v square by 2a. 20 square divided by 2 into 1 by 15, it will be equal to 3000 meters, or it is 3 kilometer. The acceleration of the train is 1 by 15 meter per second square and the distance traveled is 3 kilometer. So in this example, what is important is you have to understand the given conditions, as well as you should know the equations of motion. Then only you will be able to calculate the things asked in the problem. Second example is a car accelerates uniformly from 18 km per hour to 36 km per hour in 5 seconds. Calculate the acceleration and the distance covered by the car in that time. So initial velocity and final velocity is given, time is also given. Only thing is kilometer per hour has to be converted into meter per second. So 18 km per hour into 5 by 18 will be equal to 5 by 5 meter per second. So whenever you have to convert kilometer per hour into meter per second, multiply the kilometer per hour value by 5 by 18 and you will get the answer in meter per second. So u will be equal to 18 km per hour. If you multiply this by 5 by 18, you will get 5 meter per second. Final velocity v equal to 36 km per hour, which is equal to 10 meter per second, and time is 5 seconds. So acceleration will be equal to v minus u divided by t. 10 minus 5 divided by 5, this will be equal to 1 meter per second square will be the acceleration. Now formula for distance traveled is s equal to ut plus half at square. Put all the values in this equation. 5 into 5 plus 1 by 2 into 1 into 5 square. This will be equal to 25 meters plus 12.5 meter equal to 37.5 meter. So the acceleration of the car is 1 meter per second square and the distance covered is 37.5 meter. Now in these examples also you have to remember the equations of motion, then only you will be able to solve this problem. Third example is the brakes applied to a car produce an acceleration of 6 meter per second square in the opposite direction to the motion. If the car takes 2 seconds to stop after the application of brakes, calculate the distance it travels during this time. So first write down the given data. Acceleration is minus 6 meter per second square. Why? Because whenever the brakes are applied, the vehicle will be slowing down, and it is given in the problem that an acceleration of 6 meter per second square in the opposite direction to the motion. So that's why after application of the brakes, the vehicle will be slowing down. So that's why here negative sign is taken. A will be equal to minus 6 meter per second square. Time is 2 seconds. Final velocity will be 0 because after application of brakes, vehicle will be at rest, that is it will be stopping after 2 seconds. It will take 2 seconds to stop after the application of brakes. Now equation of motion is v equal to u plus at. V is 0, you have to calculate u, and value of a is minus 6 into time is 2 seconds, so u will be equal to 12 meter per second. Why we have to calculate initial velocity? Because to calculate the distance traveled you need initial velocity. So s equal to ut plus half at square. 12 into 2 plus 1 by 2 into minus 6 into 2 square. So this will be equal to 24 minus 12 equal to 12 meters. Thus the car will move 12 meter before it stops after the application of brakes. So can you now appreciate why drivers are cautioned to maintain some distance between the vehicles while traveling on the road? Why? Because after the application of brakes it will take certain time, that is in this case it will be taking 2 seconds before the vehicle stops. So that's why the drivers are cautioned to maintain some distance between the vehicles while traveling on the road, because it takes certain amount of time after application of brakes to stop the vehicle will be coming to rest after few seconds. So that's why drivers are cautioned to maintain some distance between the vehicles while traveling on the road. So this will be all about the equations of motion. Thank you for watching.